We'll go through some of the important things for this tutorial. So, okay, can somebody answer the first question that I have? When do you use this testing?
So can we say that we will use hypothesis testing when we want to verify a claim? When we want to verify a claim, then we will use hypothesis testing, sir.
That is one of the examples. Okay, Sean, so that's one of the examples. So put it wider. For example, can you put it wider for as many contexts as possible? So let's say, Grace, Grace, are you there? Okay, or Ihan? Oh, Grace. Okay, Grace. Okay, just decide who want to talk. Let's Grace talk first. Okay, Grace. So Sean gave an example. It's one of the when you want to verify a claim. So you put it in a wider context.
Maybe
Maybe
what did he mean by claim?
claim. When you want to verify a claim, this is what you have for this tutorial. This tutorial is always verifying a claim. So for example, this is that okay, you're verifying the claim that is it something more than something or something less than something. So you see, these are okay, education service claims that the average SAP score is 610. You want to verify is a claim correct or not. So this is called verifying a claim. But put it into a wider context, when do you use hypothesis testing? Verifying a claim is one of the examples.
When you develop something.
Okay. Develop something, then what happened?
You need to sell it. You need to sell it.
You need to sell it. Okay. Then you want to actually it's still trying to when you want to sell it, you're actually finding whether is the product fits a certain requirement, correct?
Yeah.
Okay. Yep, that's also in a way verifying a claim. So it's all right. So you have an example of that. So Ihan, you want to say something?
Is it when there's like a difference between the mean?
Difference between the mean. Okay. That's a bit wider. So yes, you have okay. So let's say you have verifying a claim. Okay. Then you have things like difference between the mean. Difference between okay, all these, in fact, difference between two means is what we will cover in your next tutorial. Okay, so these are all kind of scenarios. So when do you actually use hypothesis testing is, let's say when you have two measurements. Okay, these two measurements need not be average. When you have two measurements, let's say you have measurement A, you have measurement B. Okay, you know that these two measurement is not going to be mathematically equal, correct? In a sense, the two numbers are not going to be exactly the same. But what you want to find is, okay, so let me write out, although A is not equals to B, okay? This is what we call as a numerically. They are not numerically equal. What you want to find is the difference between A and B large enough that they are not likely from the same population. Okay, so this is the question that all hypothesis testing is trying to ask. A and B, you always get some differences. It could be the 5th decimal point difference. It could be the 1st decimal point difference. It doesn't matter. But is the difference large enough that they are not likely from the same population? In another words, you are actually finding the probability that these two measurements, measurement A and measurement B, measurement A and measurement B are from the same population. Okay. So this is the basis of all hypothesis testing. When do you use it? Okay, so essentially what we have so far is your one mean hypothesis testing. Okay, so this is what we cover for today, one mean hypothesis testing. We are looking at usually is a measurement different from a claim. Okay. Is a measurement different from a claim? So for example, you can actually ask question like, let's say, for example, you have Yakult. Okay, Yakult, by the claim is each bottle contains your 2 billion bacteria. Okay, you know that for bacteria is your CFU, colony forming unit. Each bottle contains 2 million. How do you verify that each bottle contains 2 million? So you can take bottle 1, bottle 2, bottle 3, and so on. So you have a certain measurement. From this, you get the average count. Maybe the average count is 2.15 times 10 to the power of 9. You have the standard deviation, which is maybe 1.2 times 10 to the power of 6. Does it meet the claim? Okay. Is this different enough that it may not be from the same population? So far, any clarification that you need? So it's testing a claim. Okay. Then how do you actually do hypothesis testing? There is actually a series of steps. Okay. So steps for hypothesis testing, you always have to follow these steps. Okay. Step 1, you need your null and alternate hypothesis. Okay. So anybody can tell me what is how do you differentiate between null and alternate hypothesis? So let's try Konara.
Null is what everyone believes to be true. Then alternate is someone makes another claim.
Someone makes another claim. Okay. So in this case, there are two situations. The null can be an original claim, right? The null, for our tutorial now, it can be original claim. But in wider difference, the null hypothesis is actually no difference. Okay. That means there is no difference between your findings and the claim. Okay, so that's now hypothesis. Alternate hypothesis means that there is a difference. The what you found is actually different from the claim. Here you also have to decide whether is it a one-tail test or two-tail test. One-tail test or two-tail test. Okay, so later we'll come to talk about it. You'll see the difference between one-tail test and two-tail test. Okay. The second one that you need is to determine the significance. Okay, the significance, so is either is it 5% or 1%. Okay, these are the usual ones that we use. We can use different ones. Okay. Then the third step, you collect your data. Okay, all of you are very good at data collection. You do experiments, whatever, you collect your data. Okay. The fourth is to then use the data to calculate what we known as a statistic. Okay, this statistic is important. Then five, okay, you actually use the statistic and compare with the significance. From then on, you go to step 6, you do your interpretation. So all hypothesis testing follow these 6 steps. The only difference will be your null hypothesis, alternate hypothesis, how you calculate the statistic. Okay, so whether it's a t-test, ANOVA, or any other test, these are the 2 main steps that's different. All right, so let's go to the tutorial itself, and we look at your null and alternate hypothesis first for question 2. Okay, so question 2A, anybody can give me the null and alternate hypothesis? Weiqi? Are you even there? Okay, Benjamin.
Hello.
Yeah, hi. What is
The null is h naught, then colon mu equals to 610. Then alternative hypothesis is h1 colon mu is the two-tailed test is not equals to 610.
not equal to 610, correct?
Yeah.
Okay, because it says it's different, ma. Okay, it doesn't mean that it's less than or more than, so correct. Now hypothesis, we use this simple h naught to determine. So h naught is that the score, and it says average score, right? So average score, average SAT, is 610. The alternate hypothesis can be HA or H1. Simply means that the average of SAT is not 610. Correct. Okay. So 2B. 2B, let's have Felicia.
The null hypothesis is mu equals to 16.3, and the alternative is mu does not equal to 16.3.
Right. So you are saying that the mu is the average age, lah, correct?
Yeah.
Okay. So you can actually say that mu or average age. Normally I just put the bar on top of the age, right? It simply tells you that it's average. Okay, so you can actually write this way. It's 16.3. Okay, alternate hypothesis is the average age is not equals to 16.3. Okay, good. So Ihan, Grace already mentioned. Kanara, did you mention something? Okay, so 6C, Kanara.
the null is less than 16.5. And I couldn't find the alternate.
Because your alternate is actually your null. Your null is actually your alternate.
Oh.
Okay. Remember back to what I wrote just now. Null hypothesis is no difference. Okay. So usually what we want to find out in most study is the alternate hypothesis. Okay. So here the null hypothesis is the average age is 16.5. The alternate hypothesis is the average age is younger, so it's less than 16.5. Make sense? Manara, do you make sense? Okay. So most of the experiment, we are looking for the alternate hypothesis, but we set the null hypothesis to accept or reject. Okay. You cannot accept or reject alternate hypothesis without dealing with the null hypothesis. Okay, later we'll go through that and see what happens. So 1D, let's have Hugh.
So I am here. For 1D, I put let's see, HO, the number of the depth, I guess, is equals to 3200.
So the average depth, okay, equals to 3200. Okay, alternate hypothesis.
H1, the depth again, it would be more than 3200.
No, you see, the student feels that Singaporean has that lesser than that. So it's not more than, it's lesser than.
Oh, it's lesser than, okay.
Okay, lesser than 320. 320. Okay. Now, when you have not equals to, that means, let's say for question B, when you have not equals to, it means that you also accept both more than or less than. That gives you, this is a two-tailed test. When you have only one side, that means you only accept, when you consider younger or older, this is called a one-tailed test. Make sense?
Yes, sir, makes sense.
Okay. You get this part, right?
Yeah.
So what does it really means is, remember what we have last week is your normal distribution. Okay. So let's say that this is the statistics that you want. Okay. This is a claim. The claim is x0. So this is actually the claim. Okay, claim. Okay. All right. Then what happens is, maybe we say that here, okay, we say that the claim is the average height of students is 173 cm. Okay. And then my calculation is that the average height of the students, my actual average height, right, is, let's say 175. So it will be somewhere here. What I really want to find out is, here is this is my calculator, okay, which is 175. What I want to find is this significant enough? Is this different enough? So basically, I'm looking at the area under the curve here. Is this more than or less than my significance? Okay. So this is a question I want to ask. Is this area more than or less than, let's say, 5% of the total area? If it's less than 5% of total area, then I say that it's significant enough, because 5% is my threshold. It's my cutoff point. Okay, if it's more than 5%, that means this area, let's say 7%, then I say that there is a difference, but it's not significant enough. Okay. So if the area, if the probability is more than threshold, okay. So in this case, if probably is more than threshold, we say that we fail to reject the null hypothesis. That means this area is more than 5%. We fail to reject null hypothesis. And if we fail to reject the null hypothesis, we accept the null hypothesis. So far, okay? Benjamin, are you
yes.
all right with this statement?
Yes, sir.
Yeah.
Okay. So this is one. The second one is when probability is less than threshold. Okay. When probability is less than threshold, that means the chances of the null hypothesis being correct is less than 5%, maybe 3%, maybe 1%. So we reject your your null hypothesis. Because we reject your null hypothesis, we actually have to accept your alternate hypothesis. So this is the second case scenario. Okay. So really, for statistical tests, hypothesis testing, it is really what we call as a crossroad. You are standing here. Based on your data, you go to the null hypothesis side or the alternate hypothesis side. If you fail to reject a null hypothesis, in this case, your alternate hypothesis is none of the problem already. Okay. Please do not bring in the alternate hypothesis when you fail to reject your null hypothesis. Okay. It's only when you reject the null hypothesis, then alternate hypothesis comes into play. So yes, some of you may ask, do we actually set the null hypothesis to be rejected? Correct. We put the null hypothesis to be rejected. We cannot reject the alternate hypothesis. Okay? We cannot reject alternate hypothesis. So this null hypothesis is almost like the default condition. Make sense?
Yes, sir.
Okay. So my question to you is this. What is the null hypothesis for your exam? Let's say this module. Which one? Is it pass? You pass the module, or you fail the module? Which one is the null hypothesis? Which is the alternate hypothesis?
So can we say that the null hypothesis is the passing the exam, sir?
Okay. I love to say that, but I will say that you wish. The null hypothesis is you fail. This is actually the null hypothesis. The alternate hypothesis is you pass. Okay? Basically, it means that if your score is insufficient, that means you have insufficient evidence that you pass, you fail. If your score is insufficient, you fail. So this is what it means. Okay? In exam, null hypothesis is you fail the exam. If you actually show that you can pass, then you pass. It's the opposite way, yeah? Okay, so let's come to your question 3. So in question 3, it is a lot more details that we need. First, you have to decide what is your hypothesis. Follow the 5 steps. Okay, these 5 steps. So hopefully you have calculated. Tracy. Yeah, get out here. Ooh, ooh. Okay, so okay, Tracy. So what is your hypothesis?
My null hypothesis is 5 minutes.
Okay, your null hypothesis is let's say mu is 5 minutes. Okay, alternate hypothesis.
More than 5 minutes.
Correct. It's more than 5 minutes. So this is a one-tail test. Okay, so you deal with that. So what is the significance level? The alpha.
0.05.
Correct. So this is alpha. Alpha equals to 0.05 or 5%, up to you. Then take this value and calculate the statistic. So in this case, which test do you use? The Z-test or T-test?
Z-test.
Z-test. Okay. So you calculate your Z statistics. What will be your answer?
I got 1.8519.
Correct. So it's 1.85. Choose to three significant figures. That's fine. So this, how you calculate is you take this value, which is actually x0 minus your mu, divide by your standard error. Standard error is your standard deviation, divide by square root of n. So in this case will be 5.5 minus 5 over 2.7 divided by square root of 100, which is here. Okay, so you get 1.85. Now, what is then the threshold? The threshold value. That means that will be your Z critical.
Is it 1.65?
Correct, 1.65. Okay, because how do you get 1.65? You want the area under a curve, this area to be 0.05. So you go to the table, look for 0.05. So 1.65, yeah, is actually slightly below 0.05. Okay, so that gives you 1.65. Okay, so now, do you accept or reject the null hypothesis?
I accepted.
Why do you accept?
Because Z equals to 1.85, which is more than 1.65.
So you are here. Okay. Now, this is here is 1.65, and then this area is 5%. But you are at 1.85 here. Is it more than or less than 5%?
More than.
Why is it more than 5%? It's the area here, you know. If you go to 1.85, what is the area under the curve? What is the area here for 1.85? See, you go to 1.85, it is 0.0322. Correct? So this area that you have, it is 0 or 3.2%. So there is less than 3.2% that the null hypothesis, less than 3.2% that the null hypothesis is correct, is true. Do you accept or reject? Go back to here. Okay, so let me help you out a bit. What you have is, since the Z value is more than the Z critical value, because your 1.85 is more than 1.65. The probability that the null hypothesis is true is less than 5%. So Tracy, do you get this statement right? Do you get this statement? Do you understand this statement?
Yeah.
Okay, you understand this statement. Right? If it's less than 5%, which is why, so you say, hence, you reject the null hypothesis. Because if it's less than 5%, you reject. If it's more than 5%, then you accept. The only way to accept is your Z critical is less than 1.65. So it's 1.65. So you reject the null hypothesis. When you reject null hypothesis, this is what happened. You reject the null hypothesis. You reject the null hypothesis. So you accept the alternate hypothesis. Okay. Therefore, you accept the alternate hypothesis. All right. Then is this answer complete?
No.
No. So what is the next line that you say?
You need to say there's sufficient evidence.
Is there evidence or that so is the transport ministry correct or wrong? Go back to your wrong, correct. So there is sufficient evidence that the transport ministry is incorrect or wrong. Let's say just put wrong, which is average waiting time is more than 5 minutes. So you have the answer. So this is the 3-step statement that you have to write for every hypothesis testing. You state this. So if the null hypothesis is more than 5%, then you fail to reject the null hypothesis, and then you continue writing. So okay, it's a very standard process for the last part. Anyone have issue with these 3 statements?
No, sir.
Okay, so this type of question can be a 10-mark question. So where do you allocate the 10 marks? Okay, very simple. Allocate 10 marks. First, this is 1 mark, 2 marks. So you have 3 marks here. Okay. Then you have 4 marks here. This part is 5 marks. Okay, you get the answer correct is 6. The critical value correct is 7. This is 8 marks, 9 marks, and 10 marks here. So this is how the marks are generally being allocated. Okay, so all these components are important. Okay. Now a little bit of English. Anybody know what IE means?
Sir, it means that is to say.
Yes, correct. But what does IE? What is IE is a acronym or abbreviation. But what is the word for IE? Anyone knows?
So does it stand for exempli gratia?
Exempli gratia is EG. Okay. This
Uh,
is this for example. Well, translate in English for example. This exempli gratia. Okay. For example, IE is at best. Okay, which means that is in English terms. So please do not use the wrong one.
Yes, sir.
Okay. So this is where I use IE and not EG. Another common grammar problem that you always have, please. If you can, okay, you know from your primary and secondary school, can you start a sentence with the word because?
No, sir.
No, right? You cannot start a sentence with the word because. But you should actually always start a sentence. Things like hence, therefore, you can start a sentence with that. Before the, if you want to use therefore, hence, hereinafter, before, in the middle of a sentence, please, it is a semicolon before that and a comma after that. Okay, this is important. Otherwise, you can do not change this into a comma. Never, 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 never change this into a comma. That's a serious grammar problem. Okay. Anyway, I'm not here to teach you English. Okay, so let's do the next question. Maximus.
Yeah, hi.
Hi.
What do I give you first?
What do you want to give me? You give me, no?
Okay, null hypothesis. I don't know how to say it. H0 colon.
Okay, null hypothesis. You just say I write it down.
Mu equals to 7.
Okay, so average pull up.
Yeah.
Is equals to 7. Alternate hypothesis.
The average pull up is more than 7.
Okay. More than 7. Okay. So this is a one-tail test. Okay, so the alpha?
Alpha is 0.05.
0.0. Then, do you use a t-test or z-test?
Use T.
What? Use E?
T.
T, correct. Because
T-test.
it's less than 30. Okay. So then you calculate your t statistic, which is what value?
I got 0.327.
Correct. 0.327. That's fine. Okay, then what is the critical value?
1.65.
Critical value is actually not 1.65. Okay, so for t statistic, for t value, there's actually another measurement. You actually need this thing known as degrees of freedom. Okay, in this case, degrees of freedom is n minus 1. So here will be 19. So how do you read t table? You have the degrees of freedom and then you want this value, right? Okay, so let me just show you. You go to t table. This is, let's say you want to go 0.05. So this is 0.05. You read this column. Then this V is the degrees of freedom. So you have 19. You read this value. So it's 1.729. Got it so far, Maximus?
Yeah, understand.
Okay. Later, I'll explain to you why is there a difference between these two. So it's 1.729. Okay, then your conclusion, do you accept or interpretation, do you accept or reject null hypothesis? Look at these two values. This is this value and this value.
So Z is more than
No, it's not Z, it's T.
T is more than the T critical.
Is it more than or not?
Oh shit! No, it's not. It's
Yeah.
less than.
Correct. So T is less than T critical.
So you accept null
Okay, you accept.
hypothesis
And
you reject.
No, you accept null hypothesis, don't reject anything. Don't touch alternate hypothesis.
Oh yes.
Okay. Then what does accept null hypothesis means?
That the average pull up is 7.
Okay, correct. That's it.
Yes.
Okay. Now, why is there a T statistic? So if you look at it, let me just, I'll show you another scenario. Why on earth we have two different statistics? Okay, let me just find this. So here, let's say you have okay, let me think, how should I put it? Okay. Let's say you have two study, case 1. Okay. So you want to find out is average of A the same as average of B. Okay, so our both cases are this. Okay, so case 2 is average of A equals to average of B. Okay, it can be anything. Can be your nutrient study, can be your weight of noodles, whatever. I don't care. Okay, but now in case 1, let's say one of you are a bit lazy. You only take two samples for either one of them. Okay, and then you come to a conclusion. So here your alpha is 0.05, so you divide by 2, so your threshold critical is actually 1.96. Okay, so this alpha divided by 2 is 0.025. Okay, so it's 1.96. Then you calculate your Z value to be 2, or you calculate your Z value to be 1.8. So here you accept the null hypothesis. Okay, this is your conclusion. In case 2, another of you is very energetic. You get 20 samples. You also find that so alpha equals 0.05, alpha divided by 2 equals 0.025. Okay. You find that your Z critical value is also same 1.96. Okay, because it's based on alpha value. And then you calculate your Z, it's also the same 1.8. The conclusion is you accept the null hypothesis. Now, out of these two are mathematically correct and mathematically and statistically correct in the first place. However, which case or which study will you be more confident about? So Max. So based on this, which study will you be more confident? Maxi?
Case 2.
Why case 2? All of you accept the case 2, you'll be more confident, right, of the conclusion, but why case 2?
Because there's more number of people, so it'll be more fair.
Correct. Sample size is larger, ma?
Yes.
Okay, so correct. This is, you are more confident. But the problem is your Z test doesn't really take into account of the sample size. It is count somewhere, but it's not that precise. So this is why we should kind of give or we should penalize for small sample size. In fact, we should penalize here for small samples. Okay. And that is why we have this t distribution or t-test. T-distribution actually expands out the graph. Okay, it makes the graph larger and larger. So in T-distribution, we have this thing known as degrees of freedom. Okay. Degrees of freedom, also known as DF. This is one of the most complicated concept in statistics. So since you're all online, please go and Google what degrees of freedom actually means. Just go and Google it. What degrees of freedom means?
So it means that each of a number of independently variable factors will affect the range of states in which a system may exist, in particular any of the directions in which independent motion can occur.
Language-wise and schematic-wise, Sean, you are correct. There's nothing wrong with this. Now, let me just ask the whole class, in fact, you yourself, Sean, when you read this to yourself, how many of you actually understand what the hell it really means? Or how many, okay, you get those who have heard Sean, or let me just go and where Sean probably get is degrees of freedom. Okay. So yeah, just basically this. Correct.
Yes, although there's a statistics, one simpler description for statistics on that page, sir.
Okay, but it doesn't matter. You can, in fact, one of the correct explanation is in this Wikipedia. This is exactly what degrees of freedom really means. But read it yourself, and how many of you, after reading it, now you can use your show hand button, how many of you actually reading it is more confused? Or you understand the words, but you never understood the meaning? Okay. I think all of you, right? And anyone actually understood the meaning? Or you read, you actually know what each word means, but collectively, you have no idea what is it talking about. Okay. Okay, you can put down your hands. Yeah. So this is what happens when you try to explain something. Okay. So let me just describe, in this case, degrees of freedom. It can be n-1 or n-2, depending. So why is degrees of freedom in most cases n-1? This is the most common case. Now, what I want to do is a simple test. I say that I have 6 numbers. That gives me 100. Okay, so quickly, somebody just shout out some random numbers. Can be positive, negative, how big, how small, I don't really care. Quick, somebody shout out some numbers.
50.
Next, quick.
20.
Okay, next.
30.
Next.
50.
Next.
60.
Next.
20, sir.
Are you sure you get 20 here and you get out to 100? So this is 50. So what is the last number?
Uh, 50, 30. So would it be 40?
How on earth you get 40? All these 6 numbers add up to 100, you know?
Is it minus 110?
Correct. Yeah, it's minus 110. Okay. So it means that when there is, let's say, X spaces to fill, okay? In this case, there are 6 spaces to fill. The degrees of freedom, the number of spaces that can vary, is actually X minus 1, or in this case, let's say N spaces to fill. The degrees of freedom that can move is N minus 1. Because when you put up the 5th number, the 6th number by equation is fixed for you. That's why it's N minus 1. Make sense? The space that can vary is 1 less than what you have.
Yes, sir.
Okay, so this is what degrees of freedom actually means. I can make it more complicated and say that all 6 numbers give you the average of 100, but it's going to give you a lot of calculation problem. So this is what N minus 1, what degrees of freedom really means. Okay, and that is exactly what this sentence is trying to tell you. Okay, the minimum number of coordinates that you can move. Okay, see, the number of independent ways that the system can move without violating any constraint imposed on it. The constraint that I impose on it is this equation have to be these 6 numbers have to be equal to 100. That's a constraint. But the way that it can move is only 5 out of 6. Okay. All right. Okay. So essentially, this is what you have. But what we also want to look at is it simply means that, okay, let me just write here. So when will T distribution be equals to normal distribution, or in this case, your Z distribution? Your degrees of freedom technically have to be very large. All right. So let's say if you look up the table, we say that if here is 0.05, or let's say we take 0.025, so it's 1.96. 0.025 is 1.96. We go to T table and we find at 0.025, how many degrees of freedom before we hit 1.96? It's actually infinite. That means it must be a very large number. The sample size must be very large. Okay, so very large is technically infinite. In reality, this number have to be, the degrees of freedom have to be more than 32,000. So, for those of you who did your secondary school A maths, you understand this. This is your limits. The limit for your T distribution to approach your normal distribution is when the degrees of freedom approaches infinity. That's it. But that's why we always, last week I tell you that you have to know your normal distribution or Z distribution very well, because T distribution is using normal distribution, but it accounts for different sample sizes. Okay. All right. So we have a lot more to go, but we will probably not necessarily do everything. So let's do question 5. After Max, who do we have? Zul? Zul fell asleep. Okay, it doesn't matter. Let's go from the bottom. Let's say Hui Ping.
Yeah. So the null hypothesis is equal to 22.3.
Okay, now hypothesis is 22.3.
Then the alternative one would be less than 22.3.
Let's see. Okay, what is the claim? It's just say that it's not 22.3. So it doesn't mean more or less. It's just equals to.
Yeah, not equal to. But
yeah, right. Okay, ask.
actually, I'm actually a bit confused because based on the lecture slides, right, when they say the standard deviation is given, right, we use Z test, right?
Yeah.
Then, but the previous question, the standard deviation is given, what, no, man?
You mean question number 4?
Yeah.
Okay. So there's actually 2 considerations. You use Z test only when 2 conditions are met. The population standard deviation is given. Population standard deviation is given, which is actually very hard to get in the first place because you need a large sample. Second is the sample size must be more than or equals to 30 at least. So here, although the standard deviation is given, but the sample size is too small.
Oh, okay. Okay, got it now.
So in this case, you use t-test or z-test?
Z-test.
Z-test, correct.
Yeah.
Because it's 45 and you have the standard deviation. Okay. So here is two-tail test. You still have the alpha. So what's the alpha?
0.1.
0.1. Okay, but it's a two-tail test. You have to divide it by 2. So you use 0.5. Okay, so you calculate your Z statistic. What is the Z statistic?
It's a negative value, right?
Yeah.
Negative 0.107.
107. How do you get that?
Eh! Oh no. Okay. Oh no. Because I did it wrongly. I did the left. I thought it was a left tail test.
Yeah, if it's a left tail test, that's fine. But your Z will still remain the same, ma.
How not 21.9 minus 22. Wait.
Yeah, exactly. How is... Okay, calculate again.
Wait, it's 21.9 minus 22.3. 5. So, 0.5. Oh my god.
Remember, this is variance, not standard deviation.
Okay. Isn't it 20? So it's 25 divided by square root 45.
Okay, let's look at the equation first. The equation is x minus the mu divided by standard deviation over square root of n. Okay, but in all, because negative number is always very troublesome. The actual equation is you do an absolute here. That means you change the positive, negative and positive first.
Okay.
So in this case, you have 21.9 minus 23 or 22.3. So what is standard deviation?
25. It's the square root of standard. It's a
Square
square
root of
root.
variance.
Yeah. Okay. Yes. Okay. So it's 35 square roots.
Yeah, so which is
Uh,
25 square root is
6 to 6 to 5.
25 square root is 6.25.
35 square root, no meh? Square root 5. sorry.
By now you don't know 5 times 5 is
No.
25.
Sorry. It was a mistake.
Okay, then divide by?
Oh my gosh.
Divide
Square root 45.
by. Alright. Yeah.
Oh. Okay,
so
that
is why statistics, when you do on paper, I can give you the equation, you see, and substitute in the wrong number. Okay. So this will give you, because it's absolute already, it will give you 0.537, around there lah. Yeah, because I do absolute mah.
Oh, okay.
So then what is the critical value? Is that critical value?
Is it 1.28 negative? Wow.
1.28.
Wow.
No, it's not. Okay, 1.28. Why? Because you use alpha. You use this alpha equals to 1. Right?
Oh, okay. Then
you're supposed to use it at 0.05.
Okay, then.
So this will be still 1.65. Not 1.2 something. Yeah. 1.2 something is actually take 0.1. So you are actually looking here for 0.1. So 0.1, you are actually correct lah. In this case, it's 1.28, 1.29. Okay. But we are looking for 0.05 instead. So it's 1.65. So anyway, you get a few mistakes, but it's fine. So you have this statistic and this critical. Do you accept or reject null hypothesis? Okay. So is Z more than or less than the critical?
Z is less than.
Less than the critical. So you accept or reject the null hypothesis?
We accept.
Yes, you accept the null hypothesis.
Okay.
Okay, so what is the conclusion?
Oh my god. Conclusion.
So conclusion is you actually go back to a question and you explain what does accept null hypothesis means. In fact,
the 22.31. Yeah.
The average battery life is 22.3, 22.3 hours. Okay. All right. Good. Okay, so we have a few more. Let's say we may not be able to finish up everything lah, but okay. Let's go and do question 1 first, because the rest I can just give you an answer. The method is the same. Okay. So let's go and do question 1 first. The true false thing. Okay, so to the true false questions, just now Daniel have already done that. Jeremiah, first one.
Is it true?
Correct, true. Okay. Type 1 error. In fact, what we call this significance, right? This significance, it means the probability of type 1 error. Okay. Okay. Then Jeremiah. Okay, Hui Ping. Next one.
My
Huh?
okay, okay. Pause. I have
If
no idea.
samples are drawn from different population, yet they are similar, but they are so similar and they are not. That means they are actually different population. But then you say that they are the same population. Then you are committing. This is actually the example of a type 2 error, not false.
Okay.
Okay. So this is type 1 and type 2 error. Type 1 error is you wrongly, okay, so type 1 error is wrongly rejecting null hypothesis. Type 2 error is wrongly not significant, wrongly accepting alternate hypothesis. Okay, so there's actually these two. I know type 1, type 2 is actually very confusing, so a lot of people don't use this anymore. Okay. Type 1, type 2 error is super confusing. Okay, so okay, question 1C. So Jian,
True.
okay, everything else at significance at 5%, it will also be significant at 1%. It's false. It's the other way around. If it's significant at 1%, then it will be significant at 5%, but not the other way around. Do you understand why?
Yes.
Why?
Because like the area of like the 1% is smaller than the area of the 5%.
Then the on the x-axis is a larger value, ma.
Yeah.
Yeah. Okay. Good. Okay, Jianing, next one.
False.
If my p-value is smaller than the alpha, it means that the statistic is actually true. If your p-value is smaller than alpha, okay, let's see. So you have a curve here. Okay. Your p-value is probability. So let's say this. Okay. So this is your p-value. If it is smaller than alpha, that means your alpha is larger. So this is alpha. Your t statistic will always be in the critical region. This is the whole critical region. This is the
Okay.
this is the t critical, right, or z critical. Then your statistic, this is the there's a t statistic. It will always be in the critical region. Okay.
Yeah. Okay.
All right. Okay. So Ranjini, next one.
I put true.
True. It is true. Correct. All right. Good. Okay. So let's go back to question 6. So question 6, we look back to our Benjamin.
Hi.
Hi.
Okay. My null hypothesis is equals to 12.3.
Hold on.
Sure.
Now hypothesis. So the feeding time is 12.3. Correct. Alternate hypothesis.
Not equals to 12.3.
Yep. Not equals to 12.3. Your alpha.
0.05.
0. So alpha divided by 2 is 0.025. Okay.
Yeah.
So do you use a Z test or T test?
T-test.
Okay. So your T critical.
Minus 0.762. Yeah, minus 0.762.
0.762. Okay,
The
hold on.
T value, right?
T. Minus 0. No, critical.
Okay, I say. 2.131.
2.131. Okay, so it's minus 2.131. Okay. Because your degrees of freedom is 15. Okay, all right. So your T is minus 0.762.
Hmm.
But usually we tend to make your life easier, we do an absolute for everything. Okay. So it's 0.762, and then this is 2.131. Okay, so your conclusion?
We do not reject the null hypothesis at 5% significant value.
Right. So you fail to reject null hypothesis. Therefore, you accept the null hypothesis. And what does null hypothesis means?
That the panda will change its eating habit.
Okay, so panda eats an average of 12.3 kg of bamboo per day. Yep. All right. Okay, so you're getting quite good at that. Let's just do as much as we can. Okay, so next one is Felicia. For question 7.
Yes. The null hypothesis is the average equals to 73 and the alternate is lesser than 73.
Yep, equals to 73. Alternate is lesser than 73. So you use what's the alpha value?
0.01.
Okay, alpha equals 0.01. Okay. So here you use a z-test or t-test?
Z-test.
Okay, z-test because it's more than here. So your z critical value?
2.33.
2.33. Okay. And your z value?
Negative 1.45.
Negative 1. So you actually just do absolute, it's 1.45. Correct?
Yeah.
Okay. All right. So your conclusion? Accept or reject null hypothesis?
Accept.
Correct. Because your z is less than z critical. You accept null hypothesis. And what does it mean?
The sales.
So did the sales drop?
No.
So sales did not drop. All right. Yep, you got all your answers right. Very good. Okay. So the only thing I have not mentioned is this part. Your Z or your T, right? Your Z. Your Z or T, it is your value minus the mu standard deviation divided by square root of n. The only thing that I've not mentioned is the denominator here is also known as this thing called a standard error. Okay. Later we'll talk a little bit about it if we have time. If we do not have time, we'll wait for the next lecture. Okay. Okay, question 8, prepared by Ihan. Ihan, are you there?
Yeah.
Yeah.
The null hypothesis is mu equals to 3.74.
Right now, 3.74.
Then the alternate is mu is less than 3.74.
Right, less than 3.74. Okay, then the alpha?
0.01.
0.01. Okay. So you use Z-test or T-test?
T-test.
Okay, why use T-test?
Because it's less than 30.
Okay, so it's 16. Okay. But because you use your T-test, what is your degrees of freedom?
15.
15. Okay. So your T critical value,
Uh,
which is actually equals to
2.602.
So you have to write down 0.01 and degrees of 15 is 2.602. Okay, correct. So your T statistic?
Negative 0.742.
Negative 0.742. So you just do absolute, it gives you 0.742. I always do an absolute because it makes your reading a lot easier, especially when it comes to two-tail tests.
Okay.
So what is the conclusion then?
Conclusion is 0.742 is less than 2.602. So we reject the null hypothesis.
It's less than you accept, not reject.
Oh.
Yeah.
Oh.
Because you think about it, right? This is the area that you reject. This is when you reject null hypothesis. The rest of it, this area is you accept the null hypothesis. Okay. So at this point, this is 2.602, but you are somewhere here. So you accept the null hypothesis. So if you do not know, you can't draw it out. So this is your 0.742 is within the acceptance range. This area here is 0.01, and then this value is 2.602. That's how you read the whole table. Ihan, you get what I mean?
Yeah.
Okay, so here you fail to reject null hypothesis, and then what does it mean?
It means that the cost of the rice did not fall.
That means that no, you just read this part. The average cost has not fallen. Yeah, average cost has not fallen. Okay, or you can even say that the average cost is equals stupid pen equals to $3.74. Yep, correct. Okay. Did Tracy answer just now? Did Tracy answer anything just now?
Yeah.
Grace, did Grace answer anything just now?
Yeah.
Are you sure? Okay. Fine. Okay, so you do question 9, question 10, you actually know by yourself already, to some extent. So I think the Hugh. Yes, I'm missing you for a long time.
Okay.
Okay. Yes.
Yeah, this one you have to calculate the original mean, I guess, since so numbers, which is
So, don't blabber. One step at a time. Now hypothesis, alternate hypothesis.
okay. So I don't have the answer. So the original, I think the original HO is 59 equals 59.7.
Equals to what?
59.7 because of the mean.
Okay, see the manufacturer claim that the mean of all the numbers is 50. So this is the mean.
Okay,
That's
50 is
0.
50.
Okay.
H1, I guess, would be greater than 50.
Is if its claim is 50, right? Your test alternate hypothesis, it will be not equals to 50. That means it can be any number except 50.
Okay.
Okay, so this is then your alpha is
0.05.
0.05, but then you need to change it to alpha divided to 0.025. Okay, and do you use t-test or z-test here?
Z-test.
Z-test, because you have the population standard deviation and it generates the population. So the z-test, that means your z critical is 1.96. Okay, so you calculate your z statistics. What do you give you?
Statistics. Refer to the z table.
No, the z statistic. You calculate out. So it is the average minus of the mu divided by the standard deviation over square root of n.
It's going to be about 9.51. 9.51.
9.51. How do you get that? Okay,
Oh,
so let's see.
I get the wrong number or
The
something.
average. What is the average that you get from these numbers?
I got 59.7.
Huh?
I got 59.7.
39.7.
59.7.
59.7. Okay, so 9.7. Okay, so 59.7 minus 50.
Yep.
Then the standard deviation is
10.2.
10.2. N is
The n, which is about 100.
no. It's generate from 1 to 100, but you have how many numbers here?
10.
10, correct. So it's supposed to be 10, not 100. That's why
Okay, so I got it wrong because I calculated the 100 then. Okay.
Okay, so you calculate this and tell me the answer.
3.01.
Yes, 3.01. So do you accept or reject null hypothesis?
This one.
Based on this rule?
It accept because it's greater than the z crit.
No, if it's greater, you reject.
Sorry, greater you reject again.
Yeah. So if z is greater than z critical, you reject the null hypothesis. When you reject null hypothesis, you accept
the
alternate hypothesis. Okay. So what does it mean? So you just kind of put your this sentence words.
H1 is accurate. Like,
what are you talking?
I'm just trying to figure out.
So you accept your alternate hypothesis. You actually explain what does alternate hypothesis means.
Okay.
So basically, the alternate hypothesis simply means that the average or the mean of generated numbers
It is not equal to 50.
Correct. Is equals to 50. Yeah, correct. Okay. So the difference between question 9 and question 10 is that if the standard deviation is not known, so this is where this only standard deviation is known, and then you have only 10 samples. But if the standard deviation is not known, then you have to use a t-test. Okay. So anyone have worked out? Oh, okay. There are few people who are still missing. Akil.
Yes.
Okay, question 10.
H now is 50.
Yes, it's H now is 50. Which one?
not equal to 50.
It's the same as on top, right? Not equals to 50. Okay. Then here, the alpha is the same thing. Will be alpha divided by 2 will be 0.025. Okay. So what is the degrees of freedom?
9.
9, correct. Okay. So the critical value, so is 0.025 and 9. What is the critical?
2.262.
Yes, 2.262. Okay. And your t statistic?
1.23.
1.23, correct. Okay, then what is your conclusion?
Since t value is less than the t critical, we fail to reject H null at 5% significance level.
Okay, reject H naught at 5% significance. Okay.
So we can accept H null. So basically, the mean of all the numbers generated is 50.
Yep, H naught. Okay, all right, good. So we have actually covered all of it. Are there any important questions that you still do not understand?
Sir, may I ask, with regard to question 3, question 3 of the tutorial, under the conclusion part about when we have to conclude that there is sufficient evidence at the 5% level of significance that the transport ministry is correct. Sir, may I ask, in this case, since we reject the HO, shouldn't we be saying that the transport ministry is incorrect, sir?
Yeah, lor. There's sufficient. So that's why I say there's sufficient evidence that the transport ministry is wrong.
Oh.
You know?
Okay. Sir, also, may I ask concerning the lecture notes for lecture 5. Sir, inside the notes they wrote out the statement that since n equal to 100 is greater than 30, then by central limit theorem, x bar is approximately normal for such questions. So, sir, is it possible to leave out the part for x bar is approximately normal? We won't get.
You can. Because what happened is, remember, this semester there is no paper exam, so you'll not be asked to write out all this stuff.
Yes, sir.
So you can just simply say that if the sample size is more than 30, you can use z-test by central limit theorem. That's all. Okay, you don't have to explain too much. That's fine.
Yes, sir. Just to clarify for question 4, under the final conclusion part, we should be saying that we conclude that there is insufficient evidence at the 5% level of significance that Sergeant Rambo's claim is true, sir.
You can say that, okay, but usually you want to be more verbose in your description, that's fine, but always check whether you are talking the right thing, because it's the problem that I face with a lot of students is the more you write, the more confusing you get.
Yes, sir.
Okay, so I'd rather just go straight to the point.
Yes, sir.
Yeah, that'll be easier lah.
Oh, thank you, sir.
So the thing I want to mention is this thing called standard error. Okay. Okay, so let's go for a 5 minutes break first before we come back. So we come back at about now it's 3:32. We come back about 3:36, 37. When you are back, just raise up your hand. Go for a toilet break or whatever thing first. Yeah, now go. So if you are back, then raise up your hand so I know you are back. Okay, is Felicia back? Grace, Tracy, Jianing, Wei Qi. If you're back, just raise up a hand so I know you're back. Wei Qi, Jianing. Do any of you have to go back for, do you have lab sessions this week that you go back for school for? Okay, all put down your hands already.
No, sir. We didn't have to go back to school for any lab sessions this week. I'm sorry, sir.
Is it for the whole semester or what?
Based on the lecture given by Mr. Zhang Pengzi yesterday to us, he mentioned that after the term break, we may need to go back on the first week for some practical sessions, sir.
Okay. He's Dr. Zhang Pengzi. If you call him Mr. Zhang, he may not be very happy about it. Usually he's quite okay, but try to make sure you get your titles right. Okay.
Yes, sir.
Okay. So I'm sure I drew this picture for you. The difference between population and samples is because we cannot study population, therefore we need to study samples. Now, let's say we have different samples. We have sample 1. We can do multiple samples, sample 2, sample 3, and so on. Okay. And so on. Okay. Now, the question is this: if we have samples, obviously each sample we can calculate the average of sample 1, the standard deviation of sample 1, the average of sample 2, the standard deviation of sample 2, and the average of sample 3, and so on, right? Okay, so
Yes, sir.
sample n, so this is the average of sample n, and then the standard deviation of sample n. Okay. Now, okay. So the question is, do you think all the samples, the average of sample 1, average of sample 2, are they going to be the same number? Are they going to be exactly equal? What it, do you intuitively, do you think they're going to be exactly equal? So Heiko, what do you think?
Sorry.
Okay, so this is a question that I asked. Let me just put. Okay. Question number 1 is the average of sample 1 equals to the average of sample 2 equals to the, that means is all the averages going to be identical? What do you think?
Yeah.
Identical means exactly the same number, or is it going to be close to?
Oh, close.
Close, right? So it is close but not identical. Make sense? But because it's close but not identical, this is almost a theoretical experiment. If it's close but not identical, can I say that any one of them is somewhat, can be a good representation of the population average? Let's say Zul. Okay, so the question number 2 is this. Which one is a better represent of the population average? Is it the sample 1 or any sample? Or if I take the average of all the samples, which one is a better representation of the population sample average, population average? So Zul? Zul, are you there? All right, Akil?
The average of all samples.
The average, this one will be a better, closer one, right?
Yeah.
But because it is close enough, so if you do your sampling correctly, any one of them is a sufficient representation. So although is this correct, but any sample mean is a sufficient estimate of population mean. So, and then we can actually take this. We can also take this and calculate the sample the standard deviation of the averages. Make sense? You can calculate the standard deviation of the averages. Okay. This sample deviation, standard deviation of averages, is what we call as the standard error. So standard deviation of the sample means. Okay, must be more than one. Is actually standard error. So this is what you call as SE. However, do you think anyone will actually do this experiment?
No, sir.
Right. Okay, because it's just tedious. So here is, can we kind of estimate standard error using any one standard deviation? So is there a relationship between standard error and somehow any one of these standard deviation? So what is the relationship here? Okay. We found that there's actually this relationship because at every sample there's also a sample size. So it's n1 and n2 and so on. So this is a good approximate the standard error can be approximated by the standard deviation of any sample if we take it and we divide by the square root of the sample size. Okay, that is why in your test you always use standard error. Okay, this will become more and more obvious when we go onto your t-test, the other t-test and your ANOVA. Okay, so just keep this in mind that there's such thing as a standard error and where theoretically where does it come from. Okay, so that's all I want to explain to you today. We will keep coming back to this and you will keep asking me what is standard error for a few more times at least. Okay, so we have about 1+ hour for you to view your today's lecture. So that's all for today.
Yes, sir. Thank you, sir.
Okay, have fun. Bye-bye.
Thank you, sir.
Jeremiah, are you all right?
Yes.
Okay, good. All right, that's all.